This is Ayan from Embassies. Today, I would like to share the topic Introduction to Modulation and Demodulation using LabVIEW. Here, you can see a picture. There is a microphone and transmitter, receiver that transmit the signal via channel. So, this is the communication of the module picture. So, in the context of the modulations, communications refers to the process of transmitting information from a sender to a receiver over a communication channel. And there is a key components, that's the transmitter, that refers to TX, this device that sends the information, and RX, that's the receiver and the device that receives the information, and the channel, the medium through which the information is transmitted. So the purpose of the communication system is to transfer information from source to a destination. Moving to the next slide, we discuss about what is modulation. So in the modulations, there is a message signal which contains the information is used to control the parameters of a carrier signal. This process by which the data is converted into electrical or digital signals for transferring that signal over a medium is called the modulation. It increases the strength for maximum reach of the signal. The process of extracting data that is transmitted signal is called the demodulations. And the message signal, these message signals or modulating signal may be either analog denoted by MT and the digital signals denoted by D of T. So the message signals is referred as the equation MT is equal to A of M. This is the amplitude of the modulation signal, message signal, and the sign 2 pi fm T plus 5. This 2 pi fm is referred to the omega m, the message frequency. And the carrier signal, that could be a sine wave or pulse train, that refers to the equation Vc of t is equal to the Vc cos omega t plus theta. If the message signal mt controls the amplitude, gives amplitude modulations, and if the message signal controls the frequency, gives frequency modulations, and the message signal controls the phase, gives the phase modulations. So the signal that contain no information but have a certain phase, frequency, and amplitude, that's called the carrier signal. And the modulated signal is the signal which are the combination of carrier signals and modulated signal are modulating signals. So it is the type of signals that shown is here. Moving to the next slide. So considering now a digital signal, that's D of T gives amplitude shifting ASK. Okay, and refers to the, if the message D of T controls amplitude, that's the amplitude shifting ASK. As a special case, it also gives a form of phase shifting, is called the phase reversal keeping. Now considering a digital message D of T, if the message D of T controls the amplitude, gives amplitude shifting ASK. As a special case, it also gives a form of PSK, that refers to the phase shift gain. If the message signal controls the frequency, that's called the frequency shift gain FSK, and control phase as well as it's called the phase shift gain PSK. In the discussion of the DT is a binary or two level signal representing 1 or 0, that's representing in the picture, and the types of modulation produced ASK, FSK, and PSK are sometimes described a binary or two level, binary FSK, binary BFSK, BPSK, and thus there are three types of digital modulation: ASK, FSK, and PSK. Why use modulation? So the need of modulation, that to transmit signals over the long distances. Baseband signals like voice or data are low frequency and can't travel far. Modulation shift them to higher frequency, enable long distance transmissions. And to feed signals within available bandwidth, the communication channel like radio spectrum has limited bandwidth, so modulation helps the match signal to the channel efficiently, and that to improve the signal quality and reduce noise. Certain modulation types are more robust to noise, helps maintain signal clarity, especially in wireless or harsh environments. In the wireless communication, the modulation provides a wireless connection to transmit signal to a long distance, and earlier we used the wired system to transfer information with the help of telephonic wire, but it was not possible to spread the wires all over the world for communication. By using the modulation technique, the cost of the wire is saved. Even information can be transferred to long distance faster. The purpose of modulation in LabVIEW that simulate real communication system. The modulations help simulate how the signals are transmitted in radio, satellite, or IoT, and test RF communication modules. You can visualize the modulated signal, test them under noise, also, and design custom system. That LabVIEW lets you build your own modulation scheme for research or industrial projects. And now moving to the next topic, what is demodulations? So the process of extracting data from the transferred signal is called the demodulations. And demodulation is the reverse process to modulation to recover the signal, message signal at the receiver. If the message signal and carrier signal are modulated by transmit and over the channel, and there is can receiver end. After the receiver end, the modulated signal it can filter, it's extracting noise and other information. That's the demodulation signal we can receive. And summary of the modulation techniques: modulating our message signal are are into the modulator, and again it's the modulated signal, as well as the message signal can be analog or digital, two types. Then the oscillator carrier after the modulator, that's the amplitude modulation as well as. So modulations are two types. There are analog modulations and digital modulation. So analog modulation are three types: amplitude modulation, frequency modulation, and phase modulation. So what is amplitude modulation? It is a type of modulation that in which only the amplitude of the carrier signal is varied to the represent the data being added the signals, whereas the phase and the frequency of the signal are remain unchanged. And the frequency modulation, it is a type of modulation in which only the frequency of the carrier signal is varied to represent the frequency of the data, whereas the amplitude of the signal and phase of the signal are kept remain unchanged. And the phase modulation, it's the type of modulation in which the phase of the carrier signal is varied to represent the data being added to the signal. It is denoted by 1 or 0, while 0 by 180 degree and 1b represent by the 0 degree. In the context of digital modulation, there are three types of digital modulation. First one is amplitude shifting modulations, and FSK, frequency shifting modulation, PSK, phase shifting modulation. So analog modulation we can discuss previously. It is a type of modulation that vary in the amplitude only, remain phase and frequency are unchanged. Amplitude modulations, that's AC cos 2 pi fct plus phi. This is the equation of the analog modulation. A of c refers to the amplitude, fc is refers to the frequency, and the phi refers to the phase angle. So here we discuss about the equation as example using LabVIEW, that S of t is equal to A of c multiplied 1 plus Am by Ac sine of omega mt multiplied by cos of omega ct. Here A of c is refers to the carrier amplitude, A of m is the message signal amplitude, omega m is the angular frequency of the message signal, and omega c is the angular frequency of the carrier signal. Sine of omega mt is the message signal, and cos of omega ct is the carrier signal. So moving to the Vi, we can put this equation. So I can open Vi. So we first put an structure, suppose while loop, then right click on the block diagram and go to the express. First we need to the simulate signal. After the express, into the express you can input palette. In the input you can find the simulate signal. So the signal type is sine wave and frequency suppose 100 hertz. Samples per seconds is 1 lakhs and amplitude is 1. Phase angle 0 degree and use the signal type name. Suppose a message signal. You can put the name. Then similarly another signal. So same simulate signal and the properties of the signal is sine wave. Frequency is 1000 hertz. Phase angle is 90. Amplitude 1 and 1 lakh samples per second. And you can put this signal name is carrier signal. Then okay, and after the signal you can right click on the window block diagram. Then you can go to the numeric palette. In the numeric palette, such as operator, that's we need to multiply as the equation. We can extracting the operation. So the mentioned equation is S of t is, so the mentioned equation is S of t is equal to the A of c 1 plus am by ac sine of wm omega t cos of omega ct. So first we put the equation into the here. So accordingly we can operate this operation. So the first simulate signal, the message signal, the amplitude we can define, create, right click on the function, then create control. So amplitude and the carrier, similarly carrier signal, you can define the amplitude, create control. After this, that's amplitude, you can put this name A of M, that's the message signal amplitude, and this is refers A of C, that's the carrier signal amplitude. So AM by AC, so you can operate this function and then multiply by sine of omega mt in the message signal, multiplied into the okay. Then the operation is addition, that's the this one is the, and another is constant, that's refers to 1, and then we can multiply it by cos of omega ct, that's the another numerical operation, multiplied then right click on the operator, then going to the graph indicator, this is our vi, right click on the block diagram parent, going to the signal processing, you can find the waveform measure, then you can find the spectral, this is the spectral, and right click on the block diagram panel, going to the signal processing, you can find the waveform condition, the filtered. Low pass filter we can choose, and the cutoff frequency is 100 Hz. As filter, we can put the demodulation purpose, and right click on the panel, go into the numerical operator, use the multiply operations. Right click on the create graph indicator filtered signal, create the graph indicator, the frequency domain signal. You can bring FFT also, this signal, and right click on the carrier signal graph, create the graph indicator, carrier signal, create message signal indicator. After that, here you can right click on the red button, create control as a while loop conditioning statement. So here we can, as the equation, we can put the operation. So finally we run the program. This is named as modulation signal, and this one is the demodulating signal. So run the program. Going to the front panel window, you can see this is the modulating signal. This is known as the demodulating signal. It is the frequency domain, the 50 graph, and this is the message signal. It is the carrier signal. So going to the front panel window, the generate the modulating signal, demodulating signal, message signal, carrier signal, and the frequency domain graph is also shown here. You can change the auto scale, and scaling you can put 0.04 support, and modulating signal auto scale is off, and you can scaling the 0.04. So the graphical representation, it is as the modulating signal. This is the message signal and the carrier signal. After the modulator, the modulating signal is generated, and this one is the extract information after the filtration process. This is the demodulation signal, and this is the frequency domain analysis. I have the amplitude. AM is the message signal amplitude, AC is the carrier signal amplitude. That's shown here, and here is the block diagram. Okay, so moving to the next slide, the block diagram of the amplitude modulation and the front panel of the amplitude modulation as well as shown here. We discuss about the frequency modulation. In this type of modulation, we can vary the frequency according with the message signal, and the other parameters like amplitude and phase remains constant. Frequency modulation, this is used in different applications like radar and radio telemetry processing. So here we discuss about the equation as an example using LabVIEW, that's S of t is equals to A of c, that refers to the carrier amplitude, cos of omega ct plus beta into sine omega nt. So omega c is the carrier angular frequency, and omega a is the message of modulating signal angular frequency. So and the beta refers to the modulating index. Modulation index represent the frequency deviation. So we can moving to the bi of this equation, the given equation, we can put these operations into the bi NI LabVIEW software. So first put this equation here. Accordingly, we can do the operation. So right click on the block diagram panel, go into the function palette. Into the function palette is the structure. Into the structure, you can find the while loop. First, we can put the while loop. Then right click on the block diagram panel, going to simulate signal, put here. So this is a signal type is sine wave, 100 hertz is 1000 hertz, put the frequency is 1000 hertz, phase is 90°, amplitude is 1, and samples per second is 1 lakhs. And another simulate signal we can put here, and the properties of this frequency signal is frequency is 100 hertz, phase is 0°, amplitude is suppose 4, samples per second is 1 lakhs. And okay, another signal, the properties of this 1000 hertz, amplitude 1, phase is 0°, 1 lakh samples per second. Okay, then going to the function palette, you can find the numeric, and into the numeric the cos function required, so you can search here the cos function, cos, cosine, and as well as sine function we have required, as the equation is cos and sine. Sine signals, here. Then the signal operated that's a multiplied, going to the numerical palette, multiplied operation, and then another numerical operator, multiplied is also required. After that is plus operator, so this is cos omega ct, and this is sine omega mt. Right click on the panel, addition, and then the graph waveform generation, frequency modulation graph, create graph indicator, put the name as frequency modulation, right click on the, then create control, and then going to the front panel window. Here you can see the frequency modulation graph is generated. You can change the scaling, 0.04 suppose. This is the deviation of the frequency graph, and the frequency module has been generated. So this is the VI of the frequency modulation, and the block diagram of this equation of the frequency modulation. Front panel also show here. So accordingly, we conclude this session as the modulation and demodulation, as well as the frequency modulation and amplitude modulation we discuss on the topic, and lastly we conclude the session, and thank you.